This video is a quick video review of the periodic basics worksheet. Just want you to have the right answers, number one, and number two, understand what I want you to learn from this. So the first thing you had to do was fill out all these boxes on page 2. I'm going to do this lithium one for you, and you'll notice I have a periodic table open at the same time. So I click open that periodic table and find lithium. And then with the text tool in Cami, I can put a number 3 here because lithium is number 3. This slot gets the name, and then down here goes the average atomic mass. Protons, that's the same as the atomic number. So lithium's number 3, that means 3 protons. Protons are positive, and electrons are negative. You need to memorize that if you haven't yet. That means that if I have 3 positives, I also need 3 negatives. And finally, the neutrons just add mass to the whole atom. So the protons have a mass of 1 amu each, and the neutrons have a mass of 1 amu each. So a proton plus a neutron makes 2 amus. Well, we look at our average mass here. 7 amus, so 3 plus 4 more neutrons gives us a total of 7 amus, and that is how you finish these top boxes from the periodic table. Bohr diagrams. First layer can hold up to 2 electrons. Now we need to do a total of 3, so I will put the first 2 into the first shell. And then to get that third electron, I will add that one to the second shell. Okay. You'll notice I've done a similar thing with beryllium. First 2 on the first shell. Then this time I'm trying to get up to 4 electrons, etc., etc. Each step, in case you hadn't noticed, is 1 more electron than the last. So lithium was 3. Beryllium is 4 electrons. Boron is 5. Carbon is 6, nitrogen is 7. Okay, you kind of see that pattern there. That is by design of the periodic table. And then with the Lewis structure, we just look at the outside shell only. That's called the valence shell. We can see that lithium has 1 valence electron, so we give it 1 dot on the Lewis structure. Beryllium has 2 valence electrons, 2 dots on the Lewis structure. 3 for boron, 4 for carbon. I bet you can guess what's going to happen for nitrogen. With 7 electrons, there's 1, 2, 3, 4, 5, 6, 7. Look at the outside shell. 1, 2, 3, 4, 5 electrons in the valence shell for nitrogen. I don't even have to do all these Bohr diagrams at this point to know what's going to happen. Oxygen is going to have 6. I'm going to make these a little less bright. And we're going to go a little smaller because they're going to get crowded. Fluorine is going to have 7. 1, 2, 3, 4, 5, 6, 7. Neon has 8. And then it all starts over again down here with sodium has 1, magnesium's going to have 2, aluminum's going to have 3, silicon will have 4, this will have 5. Now you, of course, you need to do these Bohr diagrams as well, and you need to fill in the periodic table info. I'm just showing you the pattern here. Go ahead and pop into the next video where I will look at the last page and talk about how some of these patterns can help us. Welcome back. We're taking a look at the last page here of the periodic basics worksheet. Number 1, which elements had complete outer shells? Well, the outer shell is the valence shell. You'll notice that everything in the first row, just hydrogen and helium, only has 1 shell. Everything in the second row has 2 shells, and everything in the third row has 3 shells. Not a coincidence. Pretty neat. So really, if I'm looking for a full outer shell, for the first shell, that means 2. Because the first shell can only hold 2. So helium has a complete outer shell. If you have two shells, the second shell can hold up to 8 electrons. So neon has 8 in the outer shell. 1, 2, 3, 4, 5, 6, 7, 8. And then argon, if you finish this worksheet, this one also has 8 in the outside shell. Because the third shell can hold 8, that one is complete as well. So helium, neon, and argon. It's interesting. All three of those are in the same column on the periodic table. Neon and argon. What do you notice about the location of the elements in number 1? Okay, they are all in the same column. And if we look over on ptable.com, we see that that column is number 18. So helium, neon, and argon are all in column number 18. Which elements had only one valence electron? Well, you know, Lewis dot structures, those ones have the valence electrons. So if we just look at the Lewis drawings, we just got to find the ones with one dot. So that would be sodium, lithium, and then hydrogen. I didn't finish yet, but that's 1 electron. They all have 1 valence electron. And again, isn't it interesting that they're all in the same column, in this case column 1. What was it? Hydrogen, lithium, and sodium. All in column 1. What do you notice about the number of valence electrons as you move from left to right? Sodium, magnesium, aluminum, silicon. Well, let's go look. Again, Lewis structures. Sodium has 1. Magnesium has 2. Aluminum has 3, 4, 5. Isn't that interesting? Okay, not a coincidence. The periodic table was built this way. There are secrets inside of it to help us understand the structure of those elements. Okay. And then earlier I already said the answer to number 6. If you go from hydrogen down to lithium and then down to sodium, what do you notice about the number of shells? 1 shell, 2 shells for lithium, 3 shells for sodium. We're adding 1 shell each step down. In fact, look at these group numbers again over in ptable.com. Everything on the first column has 1 valence electron. Beryllium and magnesium, those are both in group 2, and they have 2 valence electrons. Then we skip over to boron and aluminum. Boron's over here and aluminum's over here. Both of them have 3 valence electrons, and they are in group 13. Carbon, silicon, 4 dots on the Lewis structure, 4 valence electrons, and they're in group 14. It's all connected. We can skip ahead all the way to the end. Neon and argon, they both have 8 valence electrons, and they are in group 18. So you don't even need to draw these Bohr diagrams like I made you do, right? You can see from a Bohr diagram how many valence electrons an element has, but you don't need to draw that whole picture. You can just look at the periodic table, and from what column it's in, it'll tell you how many valence electrons. So that makes these questions pretty easy. The ones with 1 valence electron, those are group 1. Lithium and sodium. The ones with 2 valence electrons, that's group 2, beryllium and magnesium. I'm not going to do all these. Let you figure that out. You notice I skipped hydrogen. And the reason is because hydrogen is special. Everything in group 1 is a metal, except for hydrogen, right? All these things are metals, but hydrogen is put into group 1 because it still has 1 valence electron. So What I really want to know is, what's your opinion? Does hydrogen belong here? It does have one valence electron, but it's not a metal. Last but not least, using what I just taught you, you should be able to tell me how many valence electrons does barium have. It's way down here. This isn't one of the elements in our pictures here, but now you know where it is in the periodic table. I want you to add a couple more to this worksheet. I want you to do iodine, and I want you to do tin, which is SN. And those will be added to your score on this worksheet. So, that's it.